Okay, what's going on, folks? Yesterday we were learning about gravitational energy. Today we're going to be learning about how to calculate kinetic energy. So goals for today, I can relate the mass and velocity of an object to the amount of kinetic energy it has. And then hopefully you can use this relationship to solve problems involving kinetic energy. Agenda for today, you're going to take notes on how to calculate the kinetic energy of an object. And then you're going to practice calculating the kinetic energy of an object. Kinetic energy of an object is determined by how fast the object is moving, right? So remember that things with kinetic energy have to be moving, and how massive the object is. The formula for calculating the kinetic energy can be found below. And so that's kinetic energy equals 1/2 times mass times velocity squared. So Ke is kinetic energy, m is the mass of the object, and v is the velocity of the object. Okay, so our variables, we have kinetic energy, that's symbol Ke. We measure energy in joules, doesn't matter what type of energy is, so whether it's kinetic energy or gravitational energy or elastic energy or electrical energy or work, right? All types of energy are measured in joules, and that's abbreviated with a J. Joules was a famous scientist that did some work with energy. Next variable is mass, symbol M, unit. Mass is measured in kilograms, at least when we're trying to calculate energy it is. And that's abbreviated as kg. And then last up is velocity. Velocity has symbol V. Its unit is meters per second. And it's abbreviated meters/seconds. Or m/s. Okay? And so then let's go through an example. Alicia is driving a 9,100 kilogram semi-truck at a velocity of 20 meters per second. How much kinetic energy does the truck have? So that's our unknown, how much kinetic energy the truck has. We know the mass, that's 9,100 kilograms. And we know the velocity, that's 20 meters per second. So then we're going to plug those values into our formula. Ke equals 0.5 times meters times velocity squared. We don't know Ke, but we do know the mass, that's 9,100, and we know the velocity, that's 20. So the first thing that we're going to do is we're going to square this 20. Remember, that comes from PEMDAS. The second letter in PEMDAS is E for exponent. So we're going to do our exponent first. And we're going to do 20 squared. Remember, 20 squared does not mean 20 times 2. It means 20 times 20. Anything squared is just multiplied times itself. So we're going to do 0.5 times 9,100 times 400. That comes from 20 times 20. 20 times 20 equals 400. Okay, then we're going to multiply those three values together. And we should get 1,820,000 for our kinetic energy. And then just remember that kinetic energy is measured in joules. That's our final answer, 1,820,000 joules. Up next is Priska. Priska is standing on the Burj Khalifa in Dubai. That's the tallest building in the world. She drops a 0.0025 kilogram penny from the top of the tower. Before it hits the ground, the penny is traveling at 127.1 meters per second. How much kinetic energy does this penny have? Okay, so we're solving for Ke again. We don't know what the kinetic energy is. We do know the mass of the penny, that's 0.0025 kilograms. And we also know the velocity of the penny, that's 127.1 meters per second. Okay, so Ke equals 0.5 times m times v squared. And so then we're going to plug in for the mass and the velocity. The mass is 0.0025. The velocity is 127.1 squared. Okay, so remember, our first step is going to be to square this value. So we're going to do 127.1 times 127.1. And that's going to get us to 16,154 approximately. And then we're going to multiply that times 0.5 times 0.0025. So the kinetic energy should work out to be about 20.2 when we multiply those three numbers together. Or remember, we need to include the units J for joules. So the kinetic energy is 20.2 joules. Okay, example 3. Asia threw a baseball at 15 meters per second. If the baseball has 16.3 joules of kinetic energy, what is the mass of the baseball? Okay, so now we know the kinetic energy, that's 16.3 joules. We're looking for the mass, that's our unknown. The velocity is 15 meters per second. Okay, so we're going to plug them into our formula. Ke equals 0.5 times m times v squared. We're going to plug in the kinetic energy, which is 16.3, and the velocity, which is 15 squared. And then we're going to solve for m. Okay, so again, we're going to start this off the first way by squaring 15. So that means 15 times 15. So 225. Then we're going to multiply that value times 0.5. 16.3 equals 0.5 times 225. 16.3 equals 112.5, right? That came from 0.5 times 225. So multiply that times that, and you should get 112.5. Okay. Okay. Sorry about that, folks. Okay, so here's where we left off. We had 16.3 equals 112.5 times m. So then our next step is going to do, folks, a few mistakes on this slide. So we've got 16.3 equals 112.5 times m. So then our next step is going to be divide both sides by 112.5. Okay, and so then when we do that, we should get 0.14 equals m. Remember that m is measured in kilograms, so m equals 0.14 kilograms. That's our final answer. Okay, and then one last example. Lacey has a 3-kilogram cat that is running in her backyard. If the cat has 84.4 joules of energy, what is its velocity? So 84.4 joules. Mass is 3 kilograms. We're looking for velocity. So Ke equals 0.5 times m times velocity squared. We're going to plug in 84.4 for Ke. I'm going to plug in 3 for the mass. So then our first step should be to multiply 0.5 times 3. That's 1.5. Then we're going to divide both sides by 1.5, right, to get v squared by itself. 84.4 divided by 1.5 is 56.3, and that equals the velocity squared. Now, to get velocity by itself, we're going to need to take the square root of both sides. So we're going to do the square root of 56.3. And that's going to equal 7.5. So that's our velocity. And then remember that velocity is measured in meters per second. So 7.5 meters per second equals the velocity. Okay, then we've got 4 practice problems here. Give those a try. Let me know if you have any questions.